Very good morning to all. So, so far that in the computer network subjects, we have discussed about the various important topics like basic fundamentals, different kinds of networking components, and and the various kind of topologies we are following, and OSI model. So, likewise, the different kinds of the concepts we have gone through. So, in this class, let us discuss about the important protocols which is available on the computer networking. So as you know that the protocol is a what is meant the protocol? Do you have any other idea? That is a protocol is a set of rules and regulations. Set of rules we are following for making communication between the sender and receiver. So that is the main objective of using the protocol. So in between the sender and receiver, whenever we want to transfer some kind of packets, there is a necessary to maintain the corresponding protocols. By using that protocol only, we can achieve the communications, reliable communications we can achieve. So that is the main purpose of that. So in this class, let us have a discussion of the use of TCP protocol and as well as the UDP protocol. So what is the meaning of TCP and what is the meaning of UDP? So TCP is a transfer control protocol. UDP is a user datagram protocol. So before start the class, let us have a discussion of the TCP. Why we have called it as a connection oriented protocol? Because if we want to transfer any kind of packet from sender to receiver, initially we have to establish the connection. Then the data transfer will be happen. After the data transmission is over, your connection should be terminated. So, so that's a kind of actual procedure we are following for any kind of communication between the sender and receiver. That's a TCP. It will support the connection oriented protocol because there will be either acknowledgement or no acknowledgement we are receiving from the receiver side. So that is the thing. And the TCP, it will support the process to process communication as well as the full duplex communication. So as we know that there is a full duplex, it means that a single device can be act as a sender and receiver at the same time. Okay, so that's a kind of the transmission control protocol. And the next one is a UDP protocol. UDP protocol, we can call it as it's a connectionless protocol. Why we have called it as a connectionless protocol? It means that it's a unreliable transport protocol. That is there is no guarantee for delivering the your packet is successfully received by the receiver because it won't receive any other either acknowledgement or no acknowledgement. So your data may be successfully received by the receiver or it may not successfully received by the receiver. We doesn't know about that. So that's why only the UDP protocol we can call it as it's a connectionless protocol. So where we are using this TCP and UDP protocols are. So actually these kind of the TCP and UDP protocol we are using in the transport layer of a OSI model. So in between that sender and receiver, while we want to transfer any kind of packets, there is a necessity to follow such a kind of transmission functions. Now let us discuss about the overall structure of your the various kind of protocols we are using in our OSI model. So here you can see that in the physical layer as well as logical layer, data link layer, you can have the network connections, LAN or otherwise WAN connectivity we are establishing. And in the network layer only the maximum number of the internet network protocols we are applying. So that's IGMP, ICMP, ARP, RARP. So these are all the some kind of protocols we are applying in the network layer. So that's the Internet Control Message Protocol. ARP means that Address Resolution Protocol. RARP means that Reverse Address Resolution Protocol. So each and every protocols can have a individual functionalities. So based on but all those things, it is mainly suitable for routing the packets from sender to receiver. Then the next layer is a transport layer. The transport layer, the protocol which is supported in this layer is a TCP or UDP layer. Okay, we have enough discussed about the functionalities of TCP and UDP protocol. Okay, fine. Now let us move on to the application layer. As you know that there is a end users applications. The user can connect with the systems through the application layer only. So that is here various application basis protocols we have applied. The SMTP, FTP, TFTP, DNS, SNMP, BOOTP. So likewise the various kind of the other protocols we are using. That's a SMTP means that is a simple mail transfer protocol. FTP file transfer protocol. TFTP means trivial file transfer protocol. DNS domain namespace. SNMP simple network management protocol, and the BOOTP which is suitable for that's a kind of a protocol which will support to boot your machines to make an interaction with the individual machine, individual receiver, or it may be a remote machine. Now let us discuss about the basic features of a TCP. So TCP, for what purpose we are using? So TCP protocol we are using exclusively for reliable communications, reliable data transmission purpose only we are using that TCP protocol. So that is there is no losses will be happen while we are sending the packets from sender to receiver. Then the next one is a flow control mechanism. It supports the flow control. So flow controls, it means that that is a, if you want to send any other packets, your data may be sent through some kind of sliding window protocol, it may be applied, or go back in ARQ method, it may be applied, stop and wait ARQ method. So likewise the different kinds of flow control mechanisms may be applied, it may be supported by the TCP protocol. And the error control mechanism is also supported by the TCP. That's a like error detection and correction techniques, which is also supported by the TCP layer. Then congestion control protocol. That's why we are making, if there is any kind of congestion or any kind of traffic problem which will be arise, then we can take some decision that in order to avoid the traffic problem, what will be the solution we are going to recommend. That is either we can set it as a timely manner. So in that particular time only the first machine can interact with the another machine. So likewise some kind of the methodologies we can apply it for to in order to avoid the congestion between the through the network. So this is the actual TCP header format. So as we have already discussed, that is a while we want to transfer any other data or otherwise packets from one node to another node, so there should be a header field. The header field, what is the meaning of header field? Any answers? So yes, the header field, it denotes the source and destination address of the data, original packet. So if you want to transfer any other packets, so the header field, it consists of source port address and destination port address. That is a 16-bit of address we are using. Then sequential numbering methods also we are using. What is the purpose of sequential numbering? So sequential numbering, it denotes that which packet have come at first, which packet have to be transmitted the next. That's a, in addition to that, the packet name of the packet, the one additional number, sequential numbering is also added. That's a, after one only the two, the packet 2 will come. After 2 only the 3 will come. So likewise it goes on. That is a sequential numbering. So here at what situation that particular sequential numbering concept have been utilized? That's the question it will arise. So the actual objective is, if the size of the data is very large, then we can divide it into number of smaller segments. Then we have sent it to through the network various path. So at the end of the packet, at the end, at the place of your receiver, the receiver can get the portions of the segments of a single packet in a different order, because the packet may be travel through the various path. So your time may be vary, your travel time, your transmission time may be varied while the packet is transferred from source to destination. So it may be leads to the ordering of data may be changed. So instead of 1 2 3 4 packets arrival, so it may be changed to 5 6 1 4. So it may be changed. So how we are going to do the reassembly process at the receiver side? So that's a big question mark. So by means of seeing this sequential numbering, we can easily identify this is a number, after this only your data transmission, your packet will come. So likewise we can rearrange the arrived packets and we can get a whole original message. So that's a main purpose of sequential numbering. Then the next one is acknowledgement number. We have already known if the packet is successfully received by the receiver, then the acknowledgement number will be shared. Then the next important thing is 4 bits is allocated for H length, that is a header length. And the reserved bits, 6 bits have been reserved for reserved bits. So என்னென்ன ஃபீல்ட்லாம் கொடுத்துருக்காங்கன்னா urgent pointer, then acknowledge, push, reset, synchronize, finish. So these are all the different kinds of reserved bits which is suitable for the data transmission. Then the next one is a window size. Window size, it may be 16-bit size. So 16-bit size means that the data transmission, if the packet is successfully received from the receiver and it will provide the acknowledgement, then that particular packet is removed from the sliding window. Okay, so that is a window size. Window size we'll always keep it as the fixed one based on the transmission of a packets and receiving the acknowledgement of a packets. Your window size may be expanded or it may be shrink. Then the next one is a checksum field. So checksum field for error detection purpose we are using, and the urgent pointer, it denotes the if any kind of data transmission which is very important, very significant for transmission, then we can go for setting this urgent pointer. Then options and padding field. So in addition to the original data, some of the padding field number of ones is also added and transmitted to the receiver. So here the description of that, whatever the points we have discussed in the last slide. Okay, so you can read this content, you can get some clear idea. So here the acknowledgement number, sequential number, these are all the various kind of flag bits. Okay, so at what situation we are using that acknowledgement number, so they have given. And the data offset value denotes that the size of the TCP packet is 32-bit words. The offset of the data in current packet is the whole TCP segments. Okay, and the 3 bits வந்து reserved கொடுத்திருக்கிறது வந்து என்னது, it is for future use and are set 0 by default. Then urgent and the flag வந்து என்னென்ன flagsலாம் வந்து யூஸ் பண்ணியிருக்கோம். urgent flag, pointer flag, acknowledge flag, push, it means that it requests to the receiving states in order to push the data. It will push the data to the remote machine, that is a remote server. So that is a push. Pullங்கிறது வந்து from the server we are retrieving the some kind of informations or mail. So reset, it is used for restart the connections. Synchronization, it means that to set up the connection between the 2 different kinds of host. If 2 machines it wants to make a communication among itself, then initially it has to establish the connections. So there will be a proper synchronization among the data transmission. If the 2 machines have involved in a communication, while the first node have involved in a data transmission, the other node should be in a position to receive whatever the information they are conveying. Then the second node, if it wants to transfer any other packets, so your sender machine is in the position to receive the words of receiver. So likewise there will be a proper understanding or synchronization between the sender and receiver. Then the next one is a fin, flag bit, so which is mainly used for finish. After the data transmission is over, your connections will become released. Yeah, so that's a kind of flag bits, different kinds of flag bits and the corresponding functionalities. Then window size, we can set it. It is used for flow control between the 2 stations. We have already discussed that the shrinking and expanding of window size based on the packets what we have received and what we have forwarded. And the checksum field we have enough discussed. Urgent pointer, it may be set it as a 0 or 1. If it is very urgent pointer, then we can set it as a 1 or otherwise 0. And some of the other option fields is also available. Okay, so these are all some kind of important parameters we need to consider for TCP connection. So TCP is a connection oriented protocol. TCP, what is the meaning of TCP? Why we are using TCP? If anybody have asked that question, you have to say that it's a connection oriented protocol. It establishes the connection between the sender and receiver. After the confirmation, it has started to involve the data transmission, then the connection will become terminated. So that is the thing. So if the data is successfully received, then the acknowledgement will receive. If it is not received, then the no acknowledgement will receive. So based on which the retransmission of a packet process will be carried out. Then the next protocol is a UDP protocol. So it's a transport layer connectionless protocol. It's an unreliable protocol. So that's the best effort services it will provides. No handshaking between the UDP sender and receiver, because we have already seen there is no connection between that sender and receiver. Okay, each UDP segments handled independently of each other. So UDP segments may be lost or it may be delivered out of order. Okay, so here in this diagram you can see that at both in this set of peoples in this group, we can have a UDP and IP. So IP is used for making connectivity among the individual nodes which is available on the networks. Okay, so this is the UDP header format. So in the last slide we have discussed about the header format of TCP. It's very elaborate, but here it is very limited. There is a source port, destination port, total length, and checksum field. So these are the again the explanation of that source port, destination port, why we are using, and source port, destination port. What is the difference of IP addressing and port number? IP address and port number. Can anyone differentiate? The IP address which is used for identifying the individual machines within the network uniquely. So if you have a 10 number of machines, all the 10 machines can be identified individually by using the IP address. As like our name assigned to the different peoples. So port number means that that's which kind of applications we are going to run. So that's a port number. So IP address to identify the machine. After identification, by using the port number, we can set the which type of applications they are going to run in the server. So that's a kind of source port and destination port of address. Then the next one is the length of the data, then the checksum. So likewise, the different kinds of functionalities which is carried out by the UDP protocol also. Then finally, let us have a comparison of TCP and UDP. It's a connection oriented protocol. It's a connectionless protocol. So the TCP is a connection in binary stream format, byte stream format. Here the data will be transferred as a message format. So here it does not support the multicasting and broadcasting. This TCP support pannadhu, but it supports the broadcasting UDP. Okay, and the TCP provides a error control and flow control techniques, but it won't permit the flow control and error control techniques UDP, and supports the full duplex, and here does not support the full duplex. And TCP packet is called the segments and the UDP packet is called the datagrams. So there will be small variations of a TCP and UDP in terms of functionalities and the ordering functions. Okay, thank you, and I hope you can clearly understand about the TCP protocol as well as the UDP protocol, and the various kind of the other mechanisms or very kind of other header formats we are using, and in order to establish the connection between sender and receiver and involve in a packet transmission. Okay, so thank you. In the next upcoming slides we will have a discussion of the other protocols. So thank you, and thank you for your listening. Thank you.